Hi, welcome back. In this set of videos, we're going to talk about Chapter 12. And in Chapter 12, we're going to talk about advanced file operations. The reason why we're calling it advanced is because the previous semester, you should have gone over some of the basic file operations. So in 12.1, we're going to kind of do a refresher on file operations just to kind of remind you. Now in this, it says a file is a set of data stored. Let's get the pen going. File is a set of data stored on a computer, often on a disk drive. Now, the reason why I said often is because especially nowadays, you can store things on the cloud. You can store things on a flash drive, all these things, right? So it doesn't matter where you're storing the file or where you're reading the file. In fact, it should pretty much work the same no matter where you're going. You may just have to direct the computer somewhere else to read it from these different places. But a lot of these implements have the same implementation as if you were writing to a hard drive. So when it comes to programs, you can read from, you can write from, or you can do both, right? So where are we going to use these? Obviously in Word, processing, databases, spreadsheets, compilers. And what I will tell you is most of your programs need data. And there's kind of three places you can get data. Now there's plenty of them, but the three main is the user, the file, or three, a database. What I will tell you is that most of your applications will get data from one of these three areas. Oftentimes sharing, if not two, all of these. So let's jump in a little more. Now, I believe previously we used fstream header file. In this chapter, we're going to talk about the fact that you actually can use the IF stream, the OF stream, or go back to the F stream. When it comes to streams, the IF stream is for input. The OF stream is for output. I and O, where there's nothing out here on the F stream because F stream does both input and output. We're very used to these operators, and it works just like that, like we've used before for C out and C in and stuff like that, with the F stream, the if stream, and the O stream. Excuse me, the IF stream, the OF stream, and the F stream. Oh, sorry, forgot to say. And also, you can use EOF to test for the end of an input file. So the F stream, let's talk about the F stream. The big thing about F stream is that it's useful for both input and output. You have to specify the mode on the open statement, which is iOS in or iOS out, and it can be combined on open call. So you can do with this pipe, which is also a OR operator, you can do both. So you are allowed to have one stream that can do both in and out. When it comes to accessing a file, there are a bunch of access flags. So this area is the access flags. And you can string them along. You can pick one or two, one of them, but all of those flags have meanings. And so I'm not going to go too heavy into this grid because you can kind of read it on your own and figure it out. But it's great. You know, one of the ones I will tell you is this one's pretty interesting. So if the file already exists, the program goes directly to the end of the file. Output may be written anywhere in the file, but when you first start out, it's going to go to the end of the file and it's going to append to the end of the file from the very beginning. But you can go anywhere you want in the file. Whereas this append, if the file exists, its contents are presented and all output is written to the end of the file. By default, this flag causes the file to be created if it does not exist. So again, take a moment to read these. Binary mode's a great one. You've already know about the in and out, and then you also now can read about the truncate. So this is an example of using files. Here we have an F stream input. We're calling it in file. That's why we have designated just in, while we have an F stream output, which is why we designated output. And what we're doing here is we're sitting in a for loop, and for the first 10 lines, we're going to read in whatever's in that file, and then we are going to, and as you can see, we're reading in, and now we're going to take that number and we're going to send it out. So here is, and maybe I get this arrow backwards. This might be a little confusing, so let's do this. So we are going to be reading in, putting it into num, and now we're going to take num and output it to the file. You have to make sure you close your files. I will, by the way, take points off if you do not close your files. And I'll take a lot of points off because this is where we start to find, when we don't do this, we hold resources that the operating system probably needs to have. If you go out of scope, all kinds of weird things can happen, including you could have a memory leak. And so, again, we want to clean things up, so close is the way we do that. The default file open modes. Again, if we're using the IF stream, then it's open for input only. Files can only be written to. Open will fail if the file does not exist. So we're going to talk about how to test for that here in a second. And then an O opens for output only. File can be read from. File created if no file exists. Interesting, right? So here, if no file exists, we automatically get an error. If it doesn't exist here, it's going to create the file for us. File contents erased if the file exists. Again, this is a bad gotcha. And it's going to sting you one of these days. But I will tell you, if the file's already there, it will delete it and create a new one based on the default file open modes. All right, so these default open modes, that's what's going to happen here. Okay, now with that being said, right away, I know, Professor Waits, why the heck do we even have this separation? Because we need this separation. Most specifically, we need the separation for input-only files. Listen, people, I'm telling you right now, if you're only going to read from a file, you should be using the IF stream, because you don't want to make a mistake and output something to it. You don't want a mistake and do whatever might happen, even with F stream. Just do yourself a favor. If you're only reading from a file, use the IF stream. That way you know you can't mess it up. And also, the IF stream, if you're just reading, will be faster than the F stream. So when it comes to opening files, you can use file name flags and definition. So here we have the IF stream grade list. In this one, we are specifying, obviously, the file name. This allows us to be a little faster when we're opening our files. It's great because we're going to set up the IF stream. We're going to set up the IF stream. We're going to name it, and we're going to also point in what the file is. If the file stream object is always set to 0, if it opens failed, and this is how you can check to see, one of the ways you can check to see if the open failed, because the file stream object will be set to 0 if the open fails. I will tell you, while that does work, you're a lot better. Just, I would say, get in the habit of using the .fail method. This is so much more readable than this. I mean, well, this isn't going to truly stump a developer, but this just makes it a little bit more readable. I know what your intent is, so go ahead and use that. Now in 12.2, the file output formatting, you're going to find that it's pretty similar to cout. So you can use the same techniques with file stream objects as cout. So we got the show point, the set w with the how many characters, the set precision, etc. It does require the IO man IIP, the IO manipulate, to do this, and that is manipulate, short for manipulators. So here's an example. In this, we're opening the file. What I would tell you right away is I would take points off of this because there's no test being done here to make sure we have a clean open. So make sure you're testing that your files are open, that there's not something wrong. Then we're going to format for the fixed print notification. So here we have this fixed, which is a num. Oops, sorry. Where do we go here? Oh, sorry. We're using the fixed style. And now when we output this num into the data file, it's going to use the format for fixed point notation because of this first line that we did there. Let me erase that just so you can see it. So again, what we're doing is we're telling our stream that what's about to come next should be a fixed point notation. And so that's why when we do this line, this will come out as fixed point notation. I'm sure the next line they will show us that, right? Now, then we come along and we say, you know what? Actually, let's go ahead and set the precision to 4. So whatever comes next is going to be precision to 4, and then we're going to output the num. And there you go. That's why we've got 4. 3 makes sense. Then we're going to do it again with 2, 1, and there you have the outputs. Let's make sure that they closed. They did. So that is good. Perfect. That is how you do formatting on file. Now, trust me that there are plenty of other ways of doing formatting. We might get into that. I'm not real sure. If we get to that far into the output, please make sure if you want to know how to do more outputting formatting, there's a couple of options that we talked about, but we didn't really show examples of. Make sure you're Googling that and checking them out. And then, like I said, down the road, usually you will get into some other types of streams that you can do even more stuff. All right, when you come back on the next video, we're going to start out with passing file stream objects to functions, which is very handy, again, when you start getting to where your code is more modular and you're creating functions to handle one and one only thing. You're going to need to start being able to pass file streams because your parent program, the parent piece, more than likely should be in charge of file streams. And when a function needs to use that file stream is passed off to that function. That's when we come back. Thanks.